All right, so in this video, I want to find the equation of the tangent line to this function at this specific point, and I'm going to be doing it using first principles. So we know our equation for first principles is lim h approaches 0, f of x plus h minus f of x divided by h. So the first thing I'm going to do is I'm going to fill out this formula using this equation over here. So let's start with f of x plus h. I'm just rewriting this formula, but I'm replacing x with x plus h. So I have lim h approaches 0, 1 over x plus h minus 1. And then it's minus f of x, which is just the original function. So minus 1 over x minus 1 divided by h. Now I have to simplify this. So I'm going to make a common denominator on the top over here. I'm going to multiply x minus 1 in the top and bottom here. I'm going to multiply x plus h minus 1 in the top and bottom over here. So I have lim h approaches 0. This is 1 times x minus 1, which is just x minus 1. I'm going to write it out. Then here I have 1 times x plus h minus 1. And I have a common denominator of x plus h minus 1 times x minus 1. And this is all divided by h. I'll do two things in the next step. I will combine these two denominators over here because technically you can just combine them. And I'll also get rid of my brackets in the numerator. So lim h approaches 0, x minus 1 minus x minus h plus 1 divided by x plus h minus 1 times x minus 1. And then I'll write this h over here. That's how I combine these two denominators. I'll combine like terms in the top. So x and negative x cancel. Negative 1 and positive 1 cancel. I'm just left with lim h approaches 0, negative h over h times x plus h minus 1 times x minus 1. These two h's can cancel. So now I'm left with lim h approaches 0, negative 1 over x plus h minus 1 times x minus 1. Now, once I complete the cancellation, I can sub in my h as 0. So if I replace this h as 0, I just have negative 1 over x minus 1 times x minus 1, which is just negative 1 over x minus 1 squared. This is basically the slope of any tangent line on this equation. Now I want to find the specific tangent line that has a point at 3.5. So I'm going to use this slope equation. I'm going to use the x value over here to find the slope. So it's negative 1 over 3 minus 1 squared. So it's just negative 1 over 2 squared. It's just negative 1 over 4. So my tangent line at this point here has a slope of negative 1 over 4. Now I'm going to find the equation of the tangent line by doing y equals mx plus b. So y equals negative 1 over 4x plus b. I'm going to sub in the x and y value to find my b over here. So y is 1 over 2, x is 3, 1 over 2 equals, this is just going to be negative 3 over 4 plus b. And then I'll move this to the other side and add it. I'll do that in my calculator. So 1 over 2 plus 3 over 4 is just 5 over 4. If you won't allow a calculator, you just have to make a common denominator and add them. So my equation of my tangent line is y equals negative 1 over 4x plus 5 over 4. And now I'm going to do a quick sketch of this entire situation to explain what's going on. So we have this equation y equals to 1 over x minus 1. This is just a reciprocal function that has been shifted to the right by 1 unit. You should know how to draw this out. pretty easy function with transformations. So my vertical asymptote is now at x equals to 1. My horizontal asymptote stays at 0 because there's no transformation up or down. And there are no reflections. So my graph is in the two original quadrants like that. Now there's this point on the graph 3 and 1/2. That's somewhere approximately over here. And if you draw the tangent line on this graph, it's just going to look something like that. So I have my tangent line over there. This is the equation of the tangent line, and this over here, the y-intercept is 5/4, and the slope of this line, as you can tell, it's negative and it's kind of narrow. So the slope of the line is negative 1/4. Okay, so we did it for a reciprocal function. The second example is for a square root function. So similar process, but middle steps will be slightly different. Let's get into it. So we have lim h approaches 0, f of x plus h minus f of x divided by h. I'll sub into this equation. So this is going to be square root of x plus h plus 3 minus square root of x plus 3 divided by h. So you can again sub in your x value instantly if you want. It might make the calculations a bit easier in a question like this, but I'm just going to do it without the x value because sometimes you can test on this question without a point and then you have to still be able to figure out these steps. So I'm going to rationalize this by multiplying the top and bottom by this, but I'm going to change this sign to a plus. Multiplying the top and bottom by x plus h plus 3 plus x plus 3, basically rationalizing. I'm multiplying the bottom by the exact same thing. And basically now we're going to FOIL out the top because these are two factors. The middle two terms will cancel each other out. That's the point of rationalizing. So x plus h plus 3 times x plus h plus 3, if they're both rooted, is just going to be x plus h plus 3 without the root. And then x plus 3, root of x plus 3 times root of x plus 3 is just x plus 3. But make sure you put a bracket here because this negative is going to distribute into the bracket. Negative times positive is negative. Bottom just stays the same, never expand the bottom. The next step is you want to distribute this negative into the bracket on top. X plus h plus 3 minus x minus 3, and bottom just stays the same. So I'm just going to write it like this, but don't do that on a test. X cancels with negative x, 3 cancels with negative 3. So now I'm left with lim h approaches 0, h over h times root of x plus h plus 3 plus root of x plus 3. Now h and h can cancel, so I'm just left with lim h approaches 0, 1 over root of x plus h plus 3 plus root of x plus 3. And sum in 0 after my cancellation. So if I replace h with 0, I'm just left with 1 over root of x plus 3 plus root of x plus 3. I can combine these two because they're like terms. So it's just 1 over 2 root x plus 3. This is my slope of any tangent line for this equation. Now I'll find it for the actual point over here, which is 6 and 3. So my slope is 1 over 2 times root of 6 plus 3 is 1 over 2 times root of 9, which is just 1 over 2 times 3, which is 1 over 6. My slope is y equals to 1 over 6x plus b. I'm going to sub in my x and y value to figure out my b. So y value is 3, X value is 6. 1 over 6 times 6 is just 1. And then 3 minus 1 is just 2. So my y-intercept is just 2. My equation is y equals 1 over 6 x plus 2. Do a quick sketch of this situation out as well. So we know root of x plus 3 is just a square root function that's been shifted left by 3 units. There's no reflections. The starting point moves to -3, and it goes in the regular direction. Should probably extend this a bit more because the point is a bit further out. Now we have this point over here that's 6, 3. And if we draw the tangent line to this, it looks like that. And the y-intercept over here is +2. And the slope of this line is 1 over 6.